Hello, everyone. We're just going to give everybody about a minute or so, and then we'll get started. All right, I think we're good to start. So hello, wherever you are joining us from the world. Thank you for being here. I'm going to be your host for today. So today is the free open source tools for research, MONAI, and OHIF viewer. It's actually three presentations today. So we're going to hear first about the OHIF viewer. Then we're going to hear about MONAI, an overview of the entire project. And then last but not least, we're going to hear about the integration of OHIF and MONAI. And I'm particularly excited about this particular presentation, not only because I've used those tools, but one of the things that excite me about open source software is how integrating multiple pieces of open source software can be more than the sum of its parts. So this is one of the things that we're going to be able to see today. Before we get busy with the presentations, I want to remind anybody who's collecting IIP credits that you are eligible for 1 hour of IIP continuing education credit towards ABI SIP certification or recertification. You do have to attend a minimum 45 minutes to earn this credit, and that credit will be applied automatically to your SIIM account within 48 hours. In case you have any questions or problems, please contact info@siim.org. There is a Q&A feature in Zoom. If you look through the UI, you should see a button that says Q&A. Please use that to queue up your questions in there. And then I, as your moderator, will make sure that after the presentations are done, we'll be going through these questions and getting you answers from our presenters. In case you're stuck and can't find the Q&A feature, you're welcome to try and use the chat. I'll do my best to try and keep my eye on it. So this is the list of your panelists today. Myself, Mohamed Hussain, I'm a principal consultant in medical imaging. I'm also serving as the technical project manager of the SIIM Hackathon. This webinar is brought on by the SIIM Hackathon Committee. With us today, we have Dr. Salnor Erdal. He's an associate professor, a technical director at Mayo Clinic College. He is a technical director, Center for Augmented Intelligence and Imaging. We have Dr. Vikash Gupta. He's an assistant professor at the Department of Radiology, also at Mayo Clinic. And then Dr. Ali Raza Sadri, who is an open source software developer in the OHIF Foundation. Thank you all for being here with us today. I appreciate your time. These are all esteemed speakers. And without further ado, I'd like to start the presentations by passing it to Ali Raza. So Ali Raza, please go ahead and take it from here.
All right, thank you so much. All right, can you see my screen?
Yeah.
All right, perfect. Thank you so much again, Mohamed. This is a great meeting indeed. So hello, everyone who joined today. My name is Ali Reza. I'm the lead architect for OHIF. Today, I'm going to talk about our platform, OHIF, which is an extensible open source web imaging solution for medical imaging. So as a matter of fact, I gave us another presentation at SIIM last year. I shared some information about OHIF, and today I'm back. I will go over the introduction for our platform for those who are new, and also dive into latest changes of the platform for everyone else that knows OHIF. And I hope this will be an exciting catch up for everyone. So let's get started. So let's first think about and talk about the problem that we face in medical imaging, basically with traditional desktop imaging applications. So we often run into issues like operating system restrictions and software libraries conflicting with each other, administrator privileges. Also in the hospital environment, it's even more tricky. we struggle with remote access and updating these applications, which all in all can slow down the reading and reporting process. So now enters OHIF as a solution, which is a framework for displaying and analyzing DICOM images. It's vendor neutral, so it works with every vendor. It's extensible with extensions and modes, making it super flexible. It's zero footprint, so no add-ons, just a web browser. And the MIT license keeps it open and accessible. So that's OHIF in a nutshell. So basically, OHIF is similar to every other web application, such as Gmail. It's a web application that you can open in the web browser. You can right now go to this URL, which is v3-demo.ohif.org, and see it in action. It supports all DICOM transfer syntaxes, is cloud ready, so it can connect to DICOM web endpoints, and with OpenID Connect, we support authentication and authorization. So OHIF has been the viewer that's being used by various academic institutions. It includes the following, but not limited to these names, and it's always growing. Notable mentions are NCI Imaging Data Commons, National Institute of Biomedical Imaging and Bioengineering, or NIBIB. Several other institutions at NIH, we have XNAT, Osiris Foundation, KIOPS, and Fu-Berlin Hospital, and QIPCM. So OHIF is not only gaining ground in academia, but also in industry as well. So OHIF has integration with big cloud vendors such as Google, Amazon, AWS HealthLake, Microsoft DICOM Web Server. NVIDIA also includes OHIF for their MONAI integration for the web. I'm showing OHIF version 2 NVIDIA MONAI integration in the right side of the slide. And also there are lots of startups out there using OHIF, and we can't always keep track of them. But it's great to see that so many companies are leveraging our platforms and our open source solutions to make a difference in the world. So evolution of OHIF has had 3 major changes, versions. OHIF v1, which was released in 2015, had 2 separate applications. And in OHIF v2, we enhanced the extensibility of the platform by introducing extensions. And the latest version that we are releasing very soon, OHIF v3, is even better pluggable workflow modes. In OHIF v3, we support advanced features such as hanging protocols, volume rendering, different segmentation visualization. I'm going to show a lot of pictures in the next couple of slides. Label maps, contours, rendering, stack of images, color images, fusion, DICOM, different modalities, ECG, and pathology viewer. So a little bit about the OHIF funding. In September 2015, Dr. Gordon Harris at Mass General Hospital received the U-24 from National Cancer Institute that made the project move forward until August 2020. From August 2020 to January 2021, we got supported from the MGH Radiology and also from Precision Imaging Metrics, or PIM in short, which is Oncology Clinical Trial Imaging Informatics Group at the Mass General, led by Dr. Gordon Harris, which was licensed out recently to UNO.io. In 2021 to 2023, we received 2 sources of funding from Chan Zuckerberg Initiative, or in short, CZI. One was for essential open source software, and also the other one was for enhancing the diversity and inclusion in the open source community. And more recently, we received another round of CZI EOSS 5 funding, which will support development until 2024. A little bit about the statistics of OHIF. It has more than 2,300 stars on GitHub. More than 700 open source projects have been built using OHIF. It is the first out of more than 1,200 open source medical imaging projects by the number of stars. It has more than 200 global code contributors, which makes us second out of the all open source medical imaging projects on the GitHub, and we have more than 13,000 downloads requests for OHIF. So let me show you some pictures to get you excited. We support lots of DICOM transfer syntaxes. Among them are basically common modalities such as MR, CT. We have support for slide microscopy. We have support for DICOM PDF and DICOM ECG, RT-Struct for nuclear medicine, segmentations as label maps, overlays, and also structure reports and ultrasound. So these are just a few screenshots of what you can basically visualize inside the OHIF viewer. You might ask, okay, how does OHIF get the data from? We can get data we can get connected to various DICOM servers, including Google Healthcare API, Azure DICOM server, AWS Health Lake, or open source DICOM server alternatives such as Orthanc and the SIIM for SIIM. Also, you can have your data hosted somewhere statically and just connect OHIF to read from that bucket. I have a good news, which is Nifty support has been completed, the development, and we will ship it soon. So OHIF soon will have support for rendering and annotating Nifty files. A little bit about the architecture of OHIF version 3, which is our latest version, which we will soon release. We thought about the core functionalities that basically every use case has. For example, we noticed that, for example, measurement it can be used for tracking. AI can have basically measurements. Other use cases might have measurements as well. So we thought, okay, so let's take out that measurement functionality and put it into an extension. Then we introduce another layer on top of extensions called modes or workflow modes to enable a workflow to pick the extensions that it needs to achieve the use case, and then the data sources that it needs, and also builds an app based on that configuration, a single page application, and register it at the URL. I'm going to talk about this in more detail. So by having this workflow mode centric viewer, you can design your modes, which are just configuration files, to have many different viewers inside one viewer. For example, if you go to our demo, when you open a study, you can see the basic viewer and also the total metabolic tumor volume workflow mode. So in the basic viewer mode, we have support. Basic viewer mode is our measurement tracking mode that has all the annotations. You can annotate images and then finally export it to DICOM structure report. And also total metabolic tumor volume is basically opening the same study in different layout that I will show. So you can see OHIF supports basically having many different viewers with different configurations, panels, tools inside the single application, and each of them are accessible in different routes. So this is our measurement tracking or basic viewer mode that you can annotate you can annotate via measurement tools, and there's a measurement panel and you can export. This is our TMTV mode, or total metabolic tumor volume, which is, as you can see, different layout, different tools, different panels, and as you can see, there is a threshold segmentation. We have support for segmentation rendering as a label map overlay. As you can see, we have a segmentation panel. And we will ship a new mode called segmentation with more advanced segmentation tools soon. So in the past year, we have made a ton of improvement that fixed many bugs in OHIF. That's a long list. So let me just highlight a few key ones that have made a real difference for our users. We have launched OHIF mode gallery so that you can just browse different modes that OHIF can get configured towards and just install it in your instance of OHIF. We are always working to make OHIF even better. One key area is performance. So for example, we have doubled the performance of rendering the frames per second when interacting with the large images such as this mammogram by improving upon our rendering library, which is called Cornerstone 3D. So on the right side, you can see the enhanced version. Hanging protocols are becoming more critical a component in the OHIF. We have enhanced the hanging protocol engine, as you can see in this video. You can just switch layouts, and it's just super fast, changing the layout with different orientation and viewports. We have added advanced context menu, which is a right click, so you can have nested menus inside the context menu. So that's a highly desirable feature that we have been asked to implement. We have added a double click to maximize the viewport. That's basically a very good user experience, and the state, as you saw when interacting with the images, is preserved when in the double click they are window leveling. Volume rendering has been added. That's a very highly requested feature as well. So that's been added to OHIF version 3. Lastly, I want to talk about one of the best things about OHIF, which is the community around it. So we got a diverse group of users, developers, testers, and a lot of people who contribute their time and expertise to make OHIF better. Here I have screenshots of our Slack channel. I will put a link in the last slides of how to join. We have over 500 imaging experts. We have our documentation, which is extensive documentation accessible at V3 Docs, and then our community forum, which is you can go to the community.ohif.org if you have a question. We hold office hours on Thursdays at 10 a.m. We have had 34 weekly office hours so far, and we take notes. So later you can join them. It's free, and ask your questions if you have. We have a newsletter that we publish quarterly, and we have 1, 2, 3, 4, 5, 6, 7 news so far. And it's we always want to keep the channel with the community open and talk about what we have developed and enhanced. And finally, our roadmap. We believe in transparency, and that's why we love sharing our roadmap with the community. It's accessible with the timeline of what we have in plan for development. Future direction is we want to finalize the V2 release very soon. 3D segmentation mode, we already have the basic viewer and TMTV, total metabolic tumor volume mode. We're adding a 3D segmentation mode, which basically we have done the rendering. I showed you the picture, but we need to enhance support for tools and exporting of the segmentation. Nifty support release integration with MONAI in OHIF V3. I showed the V2 version. We need to do the MONAI, and my colleagues are going to talk about also MONAI and OHIF next. And also finally, the new document standards such as HTJ2K. So finally, why you should choose OHIF to build your application. It's lightweight, client only. There is no server to running the application, inexpensive to deploy, easy to integrate. It's a standard compliant MIT license, and basically you don't need to reinvent the wheel. This is the team behind OHIF. Without them, we were not possible to be here, having 3 versions and a great community around OHIF. And finally, I want to thank you for your attention. Go to visit ohif.org for more information. At the end of the page, you can subscribe to our newsletter and also the link to join the Slack channel. Thank you so much.
Thank you so much for the informative presentation, Ali Reza. This has been really, really good. I appreciate it. Just a reminder for everybody that we will take questions after all 3 presenters are done. So please put your questions in the Q&A box or in the chat. And Ali Reza, I don't know if you see the little emojis flying. People are clapping. So job well done.
Thanks. All right.
With that being said, I'd like to turn it over to Dr. Salnoor Ordal, who's going to present to us about the MONAI framework. So Salnoor, without further ado, please take it away.
Okay.
Thank you for being here, everyone.
Actually, it's after a great presentation by Ali Reza, it's hard to top that one. You should have gone last. So. Okay, so let me share my screen. Okay, and presentation. Okay, I hope you can all see my screen.
Yeah.
Okay. So I will tie the stories. First, I'll give a brief about the MONAI and where we're coming from, why interoperability, integration, and user interface are so important to us. Let me start with this. So with MONAI today, our focus is really on like how can we take an AI algorithm and in open source, like make it deployable, right? How can we deploy that algorithm to a clinical environment, but with the use of open source tools? But before we tackle that task, before you deploy into an environment, you need to understand your requirements. Why are you doing? Where are we integrating? What kind of information is going to flow through that environment? You need to have a little understanding on that. So just for the sake of completeness, I'll describe like where currently MONAI deploy is fitting today. And to tell the story, I'll start with describing a basic like order-based radiology. When I say order-based, I mean an exam is ordered by a clinician, and radiology imaging is going to be performed. Then results are going to be returned for that exam, the clinical setting. Okay, so if I start with the clinical order for an imaging study, let's say a physician has a question on, let's say, a mammography or a measurement, a tumor measurement, or a condition they're trying to check. What they're going to do today is they're going to go to their EMR and they're going to request an imaging study. And that imaging study is then going to produce an order entry in EMR, EHR, and some copies of that order will be made into hospital information system, also radiology information systems, and so on and so forth. This can be similar in the pathology setting too. So even though I'm talking about radiology, I'm sticking with one story, but you can easily replicate this flow in a pathology setting as well. So when I say pathology, I'm referring to digital pathology, by the way. In this case, that order will produce entry. Based on this entry, when a scheduler takes that order, they will scan, they will schedule the patient for a scan on a given date and time at a given location for that exam to be performed. Once those images are acquired on the scanner, they'll be routed to different systems such as, like, it can be your PACS, picture archive communication system, or your random user archive, depending on you have a deconstructor or traditional PACS system, it will go to those destinations. And it can be also routed to radiology workstations for reading. Okay. At the time of the completion, when the scan is completed, even though images are being sent, those images can be sent asynchronously, but when the technologist who's performing the scan completes the exam, that will most likely produce a trigger on a reading work list on a radiologist's workstation. And there, the radiologist will open that exam for viewing. We'll look at the additional information on the hospital information system, we'll write a report, and that report most likely will go back to the hospital information system for viewing of the clinician who ordered the exam. That's like most common traditional setting. In different settings, this flow can be, some parts can be skipped or changed here and there. For example, in an ED setting, you might be ordering and reading right there, or you may be scanning without an order. The ED scanner may have privileges to create its own orders and such. So this can be more complicated. I was trying to give a rather simplistic view of the flow. And within this flow, AI algorithms can be integrated in multiple places. So we're getting into now integration into this like environment. Well, if I started with the ordering process today, in many clinical systems, there's what we call a clinical decision support system, such as ACR Select or maybe Calus. It will tell you what algorithm, or I'm sorry, what exam might be the most appropriate exam for a given patient. Okay, or at the time of routing, there might be some rules here, either AI or machine learning based, helping you route images to appropriate places. At the time of scan, you might have some algorithms, for example, doing image reconstruction. You might scan an image in one way, but let's say if you want to run a denoising algorithm or some sort, you might be producing additional images using AI, and those algorithms results are again DICOM images. And at the time of reading, in the previous steps I described, for example, if an algorithm is running between the router and the reading work list, between this router and reading workstation, it might be helping you prioritize which exams needs to be read first. Let's imagine a case, a patient came in an ED setting, they have intracranial hemorrhage, and you want that exam being prioritized. That exam, as soon as detected by the algorithm, in this case, its input would be a DICOM study, but its output would be a HL7 or some sort of message triggering the reading work list would be running here after the scanner before the reading workstation. And once it finds the finding, it would alert the physician saying, can you please take a look at this? We think there's an emergent case here. It would prioritize that exam on the work list. So as I'm describing in more and more complex cases, there are a couple things. One, everything is flowing. It can be image, it can be DICOM, it can be HL7, it can be different standards, but everything here, this engine's been flowing for years and it's been flowing within standards, okay? But traditionally today, when you're developing an algorithm, you might be developing, let's say you found a nice data set, clean data set that you collected from different various research settings. It might be nifty and such. Yes, it's great, but in a clinical setting, once the algorithm starts executing, that algorithm needs to be capable of receiving data in standards such as DICOM, or producing output in standards such as DICOM SR, HL7, FIRE, and so forth. With that in mind, the idea behind MONAI is to fill that gap and make things deployable in settings such as we're discussing here. So if you have a trained model today, the idea is once your model is trained, if you were to use and utilize MONAI deploy or MONAI core packages to wrap this application into a container or a package, it should be able to receive data within standards and pass it along. And in this case, your application can be deployed in an inference engine. That can be your Kubernetes setting or whatever you have. You can run as simple packages themselves, simple Pythonic code or a container or a Kubernetes type of environment. Then execute that and integrate it into your workflow and pass the information along to systems like PACS and so forth. Okay. Now, with this, I'm going to jump into, we're going to get more into MONAI application packages here. Then at the end of, I'll tie the story back into the how we are doing this with the OHIF and everything in place. So now, MONAI, what is a, when we said map, we coined the term here like MONAI application package. What is that? What's going on here, right? How do I make your application standards compliant, right? Okay, now. So the idea behind a MONAI application package is, imagine a container or an application package. It can be like your a set of like set of Pythonic libraries that are self-contained, reproducible, portable, and production ready for AI inference application, just like the previous scenarios we described, right? That's the idea behind a map, what we call MONAI application package. So the idea is, you want to map once, turn that application within standards, run anywhere. So you can take this into your cloud, or you can run on-prem, you can run on your desktop, wherever you want to do. But the idea behind why would you run on your desktop is, once you build your application, that's the first step you do, you test it. So, but from test to deployment, everything should be reproducible and deployable, okay? And you should be able to support such as DICOM integration, DICOM study parsing. You should be able to do general application classes to automate your inferences. And the idea is also have strong community support behind this, which we do. We have weekly meetings. We discuss new features. What else should we add? What else could we add? Just like our friends in OHIF are doing their weekly meetings, we have a similar situation on our end too. And it's open source, Apache 2.0, knock yourself out. That's the idea. Okay, so at the higher level, at the what is a diagram for a map is, you have an application. It makes use of directed acyclic graphs. It contains what we call operators, which I will touch base in the next slide. And when you package this, you can use the app packager we provide. It creates a MONAI application package, and it can be executed on what we call an app runner to test it out, or you can turn it into a container and you can ship it, anything you want with it. So now we're getting a little bit deeper into this, but don't worry, I'll keep it as short as possible and get into the screenshots or screens, like live demos. So components of a map could be like what we call an operator. You can think of like a class if you're thinking object-oriented settings in your head, and they can be formed into creating a application. And those applications or operators can be worked and operated in a directed acyclic graph setting. So what do I mean by that? So if I start with let's say I define an operator for a study that reads like incoming DICOM study. I can have one operator for selecting series A versus B, and based on which series are in play, it's going to forward operation next down the line to operation 1 or 2. So in this case, your first operator is your receiver for your input. You may have some pre-processing such as intense normalizations, Gauss stripping, or sampling, or some Gaussian filter, or some operation. Then once that pre-processing is done, and one of those processes, by the way, can be like a DICOM to NIFTY conversion, we allow that. So if you had your algorithm written in NIFTY, don't be like, hey, do I need to convert to DICOM? No, not at this time. You can still take, using one of the operators, you can still take DICOM input, convert to NIFTY, process, then process it and turn it back into DICOM. So in this case, we're following with the steps example. Then once the pre-processing step is done, next step is running your machine learning, deep learning operators. Those could be your models, your trained models. Then once it's done, you'll be producing an output from your algorithm, and the output could be in a format. It could be a DICOM seg object, it can be DICOM SR, it can be JSON, or whatever you define, right? You can produce all this. The idea is to give the full flexibility. You can take any input. Today, we were talking about DICOM standards and whatnot, NumPy arrays, the traditional. You should have flexible operators that can incorporate different algorithms. And those operators can be chained in a directly acyclic graph in a permissible manners to pass one data set to the next operator. You can create a flow. Then it can run. What you described can be executed again. I like to stress this locally on cloud or Pythonically. And you can distribute it as a Docker container. The platform will create your Docker container for you. We have packages. If you wrote your code Pythonically, you can take that Pythonic code and create a Docker container out of that. You can deploy it anywhere you like to. And the idea is features are all compatible with the MONAI framework. What we call bundles is like, if you're using an algorithm to train AI, once it comes to deployment, you want your packages to be able to sync with each other. This is already part of the package as well. Then let's jump into some quick examples. Dr. Gupta, would you like to go through the examples here?
Yeah, hi, Sanar. I can walk through the examples, and I was setting up a demo to show, so I can show some demo as well. So yeah, thanks, Sanar, and also sorry about the delay. I had some things that I couldn't escape. So yeah, here is, as Dr. Ardal was mentioning before, like MONAI application packages are built on several atomic functions. And the core component of it is an operator, and operator is equivalent to, like, it's like a function which takes an input and gives an output. So, like, for example, here you can see, like, this is a Gaussian operator, and it takes an image and it produces an image. So the key function that is to be written in this operator is a compute function, which essentially does the operation on the input and produces the output. So a couple of things I would like to mention here is that don't worry too much about, like, all the web bells and whistles written around the operator. They are something that are common to almost all the operator that you will write. So just copy this and then just worry about the compute function, which is where you will write your function. And you can get Sandra, can you go back to the previous one? Yes. And here, as you can see, like, after you write the input context, output context, execution context, and everything, you can just get your data from the operator input and then produce the output here and then save it. So yeah, the point I'm trying to say is don't worry too much about the input output context and the execution context. Just copy it, and after that, write your function. Next slide, please. So yeah, so as I was saying, that operators are one of the most basic components of MONAI application package. So and an application is nothing but a chain of operators. So for example, this is a complete code of a MONAI application, where you see, like, your operators are the ones that you would have defined earlier, and then this application chains these operators using this function like self.add flow. So the input comes into the Sobel operator, and the output of that is passed to the median, and then the output of the median operator is passed to the Gaussian operator, and the output of the application would be, if you apply these operators in series, that would be the output of this. So this is the application looks like. Next slide, please. Yeah, and like once you have written the application, you can, it's pretty flexible on how you want to, like you can run it in a couple of different ways. So MONAI deploy gives you a command line interface, which you can run it using the one in the second point, which is MONAI deploy exec my app, which is your application. Then you give the input file, input DICOM, output, and the model, and it will just run it. And of course, there's a Python interface too as well. So in which you have, like, you pass the arguments and it will do and run this application. And if you want to ship it to someone, like, if you want to integrate it with an existing infrastructure, which is containerized, and you can build a MONAI Docker container. So like, for example, in the third bullet point, what MONAI deploy package, this command is used to build a MONAI package. So, and this package is run using this MONAI deploy run, which is also provided by the MONAI deploy application runner. Next slide, please. So that is how you write an application. But can I share my screen for a second?
Sure.
Yeah, but I cannot share screen while others. So then if you stop sharing for that. Can you stop sharing? Yeah, let me get to, let me just share. Okay. So what I was trying to say is, you should know how to look for the documentation, and for doing so, you just go to MONAI deploy app SDK here, and then you will see there is of course, go try to use the latest version, or and here you have all the information, right? So first go to getting started, and then you have some sample applications here, and basically whatever is set today is there's more details here, like how to create the segment. There is one for classification application that is written here, and you will just go through it and create a segmentation application. There is also another you will find all the information here, and also you can look up all these things at GitHub. So MONAI, in project MONAI, go here, and then you'll have repositories, and MONAI deploy app SDK. And this is the code that you can have a look. And we have created a lot of tutorials for it. And I will encourage you to go through these tutorials, and like how to write a very, very simple 4-line application. So, I mean, of course, there are this thing, but you can write like a very simple Sobel operator, and it's all written here. So, this is the place you should go to find out more. And of course, if you run into some error, some issues, and that is something you're not able to resolve, you can just post it in discussion. As you can see, it's a very active community where we, of course, answers all your queries. And if there is some issue that you find a bug because of change in the versions, or if something is not happening, you can just mention here in issues, and we meet every week and resolve these issues regularly. Yeah, so this is where I wanted to show where to go to look for information. Yeah, so let me just stop sharing, and let me share again. Okay, so so yeah, this is all about how to look for information and write your own MONAI application packages. Does anyone have any questions, or do we have time for a demo? How's it going?
Yeah, you were good for a demo, and then we'll take questions after, Vikash, when you're completely done.
Because we'll also demonstrating the viewer of the OHIF part.
Okay.
So you have about like maybe 3 minutes before we can jump into
Okay,
the
so you can demo the viewer then. That is more important, actually. Yeah.
Okay.
Okay, I'll stop sharing. Yeah.
So let me share my screen. Okay. Now, so with all this in mind, what we did is before I just want to give 2 minutes to this. There's a on MONAI application zoo. There are packages we built, and those packages, one of the examples is on breast density classification. So you can download those packages. You don't have to even start from scratch to build an application. You can take a pre-built application. You can download that application and you can play with it. Trained, ready to go. So now what I'm going to show here is taking it to the next level and how we integrate two projects together, MONAI and OHIF, right? So this is one of the examples you can download. Again, Model Zoo. And if you want the full application package, here are the links. I will also post the links at the end of this live demo to the chat so you can follow them. So let me go to this. So, okay. The moment you've been waiting for, or if you're in action with MONAI. Okay. So as we discussed earlier, MONAI was intended to, okay, how do I take my algorithm, deploy within standards, and clinically deploy it? Here's an example. In this case, it's a web-based browser. It's running in the browser, but data is flowing to it. In my end, the ORThank piece that we discussed earlier, we discovered also that Alireza is sitting as a DICOM web interface, as also can receive DIMC, meaning within my system, every exam that matches the tags of for a MR brain scan gets forwarded to my algorithm for, in this case, it's a white matter segmentation algorithm. And once the algorithm receives this input, because algorithm is packaged in such a way that is compatible with, like we said, MONAI and standards, it can produce what we call DICOM seg output. In this case, this is the output you're seeing. This output can be pushed into any of our viewers. And when we modified, when we built our interfaces, we were making sure, for example, when I turn this from web browser to like a full screen mode, this, for example, top layer is matching with our clinical viewers top layers. So if the user moved their mouse from left to right, if they did any kind of windowing leveling, we make sure it totally matches the clinical viewers. Okay, that's one. So let me go to another little more complex example. This example. Okay. Now Next one is here. In this case, the first one was a segmentation algorithm. Now I'm showing a little more longitudinal. In this case, the viewer is showing algorithm being executed for the past 6 months. Okay, it shows every study it was executed on and how it was handled. In addition, I'm just to make the screen big, so we made such that everything you see on the screen is modifiable by the user. Users can choose how to view their content and what kind of content to display on them. And for example, in this case, the algorithm is displaying what we call bounding boxes. The bounding boxes in this case, again, are in DICOM passed to the viewer in DICOM SR format. When they're passed on to the viewer, when you go over a bounding box, it matches your results. Or if you find a result, you can see where it is. I can accept these results. I can delete them, reject them. I can save them, or I can send it to a destination. In this case, the SR that was generated can be sent to what we call a new a dictation engine, like in Nuance. In US, most common one is Nuance. So you can, if you want to send these results to a destination, you can do so. If you want to save the previously shown segments, you can do so. Why this is important? Because if I want to come back and retrain my algorithm based on users' feedback, it's, for example, if I think my algorithm didn't detect something, I want to create like another entry for it. Here, I think there's something else here. I'm going to call it like, just make it something. And this feedback is captured immediately. Why is it? If you want to retrain this algorithm or give feedback to developers of the algorithm, or if you send results, if I can reject all these results, I can send the one I just picked, I can send it, I can receive it. The idea is interoperability. And in this case, this is what provided. Seeing is believing. The idea is give the results to end users, let them give the feedback, let them label the data for you, because their feedback is most important. If in a traditional setting, if it's taking me 2 minutes to evaluate this patient, then I go to yet another station to label the data. That's, no one's paying for that for radiologists. That's a lot of time spent. They already looked at the case in a clinical setting, so they need to be able to give feedback, do things with it right there and then. So they don't spend like making a call here, seeing, yes, I approve this, or give a score to it, takes me 1 second, versus refining the information, doing it again in a different setting, like another 10 minutes maybe to put it all together. So that's why it was so crucial for us to be able to tie MONAI and a code base like OHIF to put it all together, such that we can deliver the content at the time of inference, and if we can receive the feedback at the time of inference with the physician's help, because they are the ground truth in this case. They set the ground truth. That's the that was our logic behind our design philosophy here. We along the way we had to make customizations, but all these customizations are possible because of the open source nature of the OHIF platform. And one of the first things we did was we were able to tie the backends for Orthanc with backends that will restore the feedbacks for OHIF, meaning the data with users' feedback. And once you have these two together, then you can retrain your algorithm or display the content at real time in context with the clinical data. That's one of the customizations we took on. It was more of a configuration at some points, but that's one of the main things we did to deliver the content real time on time. So I'm realize I'm running short on time. I just want to
yeah, we're gonna have to wrap up.
Answers. Yeah.
So if you could please stop sharing, I just need to show a couple of quick slides as we close. So for everybody listening in, if you have questions, now is a good time to put in these questions in the Q&A panel. Thank you so much to all our speakers here today. This has been very enlightening. So I appreciate your time and effort in sharing this with us. For anybody watching, you're also welcome to join any of these future SIIM activities. So there are a couple of webinars over here, and there are some training sessions that are available. I'm going to leave this on the screen just for a moment. While I let you see those and read them, a reminder that if you have any questions, please go ahead and put your questions in the Q&A box. I'm going to start with a question that came in about the importance of community engagement. So maybe each one of you can very quickly comment, like 30 seconds or so, starting with you, Ali Reza. So what's the importance of community engagement in your project? And what are calls for action you can provide to people on today's call for things they can do to contribute, not just use this project?
All right, great. Great question. So basically, to enhance the community engagement, I guess one of the key decisions we made was introducing the roadmaps. So we published a roadmap, and I can't say how much of a positive effect it had, because people saw that this is a feature that we have not planned, or we have planned, and they can prioritize their list. Also, our roadmap has a section for unfunded features that we would like to have, but we haven't secured funding for it. So there were a couple of features that was seen by someone, like for example, at Gradient Hills, which is a startup. So they saw that this is a feature that we like to add, and we don't have funding. They just went ahead and contribute that back to open source. So transparency for community engagement is a key, based on the experience that we had in OHIF. Documentation, people really much appreciate the detailed documentation, and that's something that I always push for any pull request that comes from a community. How small is that? Make sure you have documented that. So my 2 cents are documentation and transparency for roadmap.
Thank you, Reza. Just before I turn it to Salnor and Vikash, I'm going to quickly cover. Remember that you qualify for continuing education credit. It should be automatic. If there are any questions, please contact SIIM. And also, please take the post-webinar survey after we're done the call here today, because this will help us plan better. And then last but not least, thank you to the SIIM Hackathon committee, plus our speakers here for organizing this. Vikash, Salnor, do you want to comment very quickly on community engagement?
I would say it's important. The way we grow MONAI is by community support, meaning your feedbacks are driving what features we try to work on and make it more interoperable. That's what I'm going to say, interoperability. So you have to encourage community to bring their problems so we can work on them, make this interoperable and integratable.
Thank you very much. Vikash, any last words on your end?
Yeah, I will just like to say that this is a very diverse field, because it includes researchers, people in imaging informatics, and no one person knows everything. I mean, and so like, for example, someone is a researcher, they might not know a lot about FHIR, DICOM web, and all these standards. So it's important to put your questions forth so that people from the other communities can actually help. And also, when you are developing something, do not develop in isolation, because you will realize that, oh, what you developed is not ready to be used and by any hospital. So it's very important to come out and say what your needs are, and people will definitely help you doing your documentation and installation and whatever is needed. Yeah.
Thank you so much. And once again, I appreciate your time, everybody, for presenting here today, and for our attendees for being here with us. Sorry for going a minute over time. Thanks again, everybody. Have a great day, and talk to you another time.
Thank
Have a
you.
great time.
Thank you, everyone. Have a good one.